On the 2013 exam, question number 15, they're asking you for what are the values of x for which the series converges, okay? So this is what we want to do to figure this out is we want to use the ratio test because the ratio test will do that. And then we're going to need to check the endpoints, right? So this is kind of a little bit of a lengthy problem. So I'm going to do this on a separate piece of paper, okay? So I have my series, and what I want to do is I want to take the absolute value of the a sub n, right? Okay, so n equals 1 to infinity, absolute value of -1, because I'm checking for absolute convergence here. Okay, so then I'm going to take the absolute value of this, which is going to cause it to be 1. And this is the n, because n is starting at 1 and going on. This is always going to be positive. So this becomes sigma n equals 1 to infinity of 1 over n times the absolute value of x plus 3/2 raised to the n power. Okay, so we're going to do the limit or the ratio test on this. So the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Okay, that's going to be equal to the limit as n approaches infinity of, okay, so it's going to be this one with n plus 1 where n is, right? So absolute value of 1 over n plus 1 times, we're not going to have to worry about the absolute value in here, okay? So x plus 3/2 raised to the n plus 1, and then times, and it's going to have to be the reciprocal of this, right? So it's going to be n over x plus 3/2 raised to the n, close the absolute value. Okay, so I'm going to rearrange this so I have the correct terms with each other. Okay, so it's going to be n over n plus 1. And then times, this is going to be x plus 3/2 to the n plus 1 over x plus 3/2 to the n, close the absolute value. Okay, now I'm going to take, well, I'm going to hold off on taking the limit. So the limit as n goes to infinity, absolute value of n over n plus 1 times, and the reason I didn't go ahead and do it is because I want to simplify this, right? So this is going to be n plus 1 minus n, so it's just going to be x plus 3/2 raised to the n. Oh, I'm sorry, not x plus 3 raised to the n, just x plus 3/2. Okay, and then close the absolute value. Okay, and now if I take the limit as n goes to infinity, this is going to go to 1, which is positive, right? And then this doesn't have an n to plug into, so it's just going to be the absolute value of x plus 3/2. So this becomes the absolute value of x plus 3/2, right? And we know from the ratio test that this is going to converge absolutely when this value is less than 1, okay? So x plus 3/2, the absolute value of that is less than 1, okay, for sure, okay? Now, what does this mean? This means it's -1 less than x plus 3/2, which is less than 1, okay? Subtracting 3/2, so this is 2/2 and this is 2/2, right? So subtracting 3/2, it's going to make this one -5/2 less than x, and this is 2/2 minus 3/2, which is going to be less than -1/2. So I know right now that for absolutely that they converge, okay, between -5/2 and -1/2, not including these endpoints, right? So now we got to check the endpoints. That's what makes this problem take a little bit longer, right? We got to check the endpoints. I'm going to slide this up a little bit, and we're going to check those endpoints, okay? So we're going to check for x is equal to -5/2, okay? So that makes the series sigma n equals 1 to infinity of -1 to the n over n, okay, times, and it's going to be -5/2 plus 3/2 raised to the in power, okay? So this is going to be negative 5 halves plus 3 halves. That's going to be negative 2 halves, right? This is going to give you negative 1. So this is equal to sigma n equals 1 to infinity of negative 1 to the n over n times, and then this becomes negative 1 to the n, because that's negative 1 right here, okay? And then we have negative 1 to the n times negative 1 to the n, right? And that'd be negative 1 to the 2n. And so this would be negative 1 to the 2n, because we'd add our exponents here because the bases are the same, over n. But what do we know about this? Okay, so this is equal to sigma n equals 1 to infinity. And this is going to become negative 1 squared, raise that to the n, right? You can think of it like that. Or you're taking this, and this is always going to be an even number, right? So this is going to be positive 1. So this becomes 1 over n. And what do we know about this? That's the harmonic series, right? And so the harmonic series diverges, okay? So this, so we know this diverges. And we don't need to check absolute convergence or anything because the actual series already diverges, right? So it's not going to be conditionally convergent, okay? Or absolutely convergent. It diverges, right? Okay, so what does that mean? Well, because I should write this, okay? Sigma n equals 1 to infinity of 1 over n is the harmonic series which diverges. Okay, so we're not going to include negative 5 halves, right? How about x equals negative 1 half? Okay, so we got to check that one. Okay, I need another piece of paper. Okay, I knew this was going to take a while. Okay, so let me grab that. Okay, so now I need to check it at x equals negative 1 half. Okay, so I have sigma n equals 1 to infinity of negative 1 to the n over n times, and then negative 1 half plus 3 halves to the n, which is equal to sigma n equals 1 to infinity of negative 1 to the n over n. And this would be 2 halves, which is 1, right? And that'd be 1 to the n. So we have this, right? And what do we know about this one? Okay, this one converges, right? Because it's the alternating harmonic series, okay? So, but it, okay, so it's I should say this is conditionally convergent, okay? Well, okay, hold on. It becomes this, right? Okay. So if we do this, we're checking for absolute convergence, because I should go through the whole process, okay? Not just jump to the conclusion. All right. We're going to take the absolute value of negative 1 to the n over n. That becomes, and we're checking the absolute convergence of this series now, right? N equals 1 to infinity. All right, this is going to become 1 over n. And we know previously that that diverges, right? So at x equals negative 1 half, it's not absolutely convergent, right? So this diverges due to it being the harmonic series again, right? Okay, so now, all right, what is this one though? This is the alternating harmonic series, right? And we should know that because we've done this enough, that the alternating harmonic series actually converges. So it doesn't absolutely converge, okay? And so I should say this, sigma n equals 1 to infinity of negative 1 to the n over n is the alternating harmonic series which converges. Okay, so it diverges at -5/2, but it converges at -1/2. So for what values of x does the series converge? It would be negative, let's say the series, let's just say this, the series converges for, it doesn't converge at -5/2. So -5/2 less than x, but it does converge at -1/2. So -5/2 less than x, less than or equal to -1/2. Okay. And then if you go and look at our paper, I'll try to select the correct one this time. Okay. Not at -5/2, but including -1/2. So that would be letter B. It would be this one right here. Okay. All right. Now I know there's not multiple choice on the test this year, but I think they're going to ask you a lot of multiple choice type questions. Okay. All right. Okay. So that's question number 15. Let's go on to 16. So 16, they want to know what the antiderivative of 1 over 100p minus p squared is, right? Okay. So you got to realize that this is a partial fraction decomposition problem, okay? Because this can be rewritten as a product as p times 100 minus p, okay? So this is equivalent to 1 over p times 100 minus p, okay? So we got to break this up into the sum or difference of two fractions, okay? And that's the partial fraction decomposition. Okay, so we're going to do that, and this is going to take a little bit of time too, so I'm going to grab another piece of paper, okay? Okay, so I know that this has to equal sum A over P and then plus sum B over 100 minus P, right? And so if P equals, well, actually I want to multiply, I want to clear out the fractions, right? So I take that back. This is going to be 1 is equal to A times 100 minus P and then plus B times P, okay? So now we want P to be 100 and we want P to equal 0, okay? So if P is equal to 100, that's going to make this become 0 and that's going to drop out, right? So then that would be, this one would be 1 is equal to B times 100, or 1 over 100 is equal to B. Okay, if P was 0, then this one would be 1 is equal to A times 100. And then this one would drop out, right? And so 1 over 100 is equal to A, okay? So now we know that 1 over 100p minus p squared can be rewritten as 1 over 100, because that's my A, right? 1 over 100, okay? So 1 over 100 over P plus B, which is also 1 over 100 over 100 minus P, okay? And we're multiplying both of these by 1 over 100, I'm going to pull that out, okay? So this becomes 1 over 100 times 1 over P plus 1 over 100 minus P, okay? So when we go to integrate this, okay, so just the antiderivative, right? It'd be 1 over 100 P minus P squared dP. That would equal the integral, and we could bring this all the way out in front of the integral, 1 over 100 times the integral of 1 over P plus 1 over 100 minus P dP. Okay, so then this is going to equal 1 over 100. Okay, now, I'm going to put a bracket here. Okay. I'm going to break this up. This would be the integral of 1 over p dp plus the integral of 1 over 100 minus p dp. Okay, so we know that this one's going to be the natural log, right? And this one is also going to be natural log, but okay, if we let u be this, then du would be negative dp, right? So we would need a negative dp. So this is going to change to minus, okay? All right. Okay, so this is going to equal 1 over 100, okay, times, this is going to be the natural log of absolute value of p, and this one's going to be minus, and I'm just kind of doing this fast because there was a u substitution that you could do, right? And this would be the natural log of the absolute value of 100 minus p, and then plus c. Okay, so now we're going to distribute this. So this would be 1 over 100, the natural log of the absolute value of p, minus 1 over 100, the natural log of the absolute value of 100 minus p, plus some constant c. Okay. Now, they're telling you at the very beginning, right, that p is between 0 and 100, okay, but not 0. So that means we wouldn't need the absolute value on this. And if p is between 0 and 100, but not including 0 and not including 100, okay, this one also, right, would always be positive, okay? So we really don't need the absolute values. So this becomes, oops, I slid it up for you, okay? This becomes 1 over 100, the natural log of p, minus 1 over 100, the natural log of 100 minus p, plus the constant c, okay? And the correct answer for that one would be A, okay? So that would be this one right here, A. And let me circle it. Okay, I think this is just good review. I mean, we're reviewing a lot of things by doing this, okay? So let's go on to 17. Okay, so if the limit as h approaches 0 of arc sine of a plus h minus arc sine of a over h is equal to 2, which of the following values, which could be the value of a? All right, so what you have to recognize is this is a derivative, right? And we know the function is arc sine. So f of x is equal to arc sine, which is sine inverse, right, of x. And we want to find f prime at a, and I know this is 2, right? That's what this is saying. F prime of 2, if f is arc sine x, f prime of a would have to equal 2. Okay, so what we have to do is we got to find the derivative of arc sine of x, okay? And then what that would be is, okay, so f of x is arc sine of x. So f prime of x from our rules would be 1 over the square root of 1 minus x squared, right? So then f prime of a would have to equal 1 over the square root of 1 minus a squared. And what do we know? We know that this is equal to 2, okay? So I'm going to multiply both sides by the square root of 1 minus a squared. That would give me 1 on this left-hand side. And on the right-hand side, it would give me 2 times the square root of 1 minus a squared, okay? And so then the next thing I'm going to do is I'm going to divide both sides by 2 because I'm going to get to the square root and then undo the square root to get to the 1 minus a squared and so on, okay? All right, so this would be 1/2 is equal to the square root of 1 minus a squared. I want to square both sides, so that make this 1/4 is equal to, and that the squaring would cancel the square root, so I'd be left with 1 minus a squared, okay? I'm going to move the a squared over here, so that becomes positive a squared. And now I'm going to move the 1/4 back to the right-hand side, okay? So this would be 1, which is 4/4, minus 1/4, right? Which gives you 3/4. fourths. Okay, so now I know a squared is equal to 3/4. Square root in both sides, and I'm going to get a. Okay, so this is the absolute value of a is equal to the square root of 3 over 2. That means a would have to either equal positive or negative the square root of 3 over 2. Now, there's only one choice here, right? And that would be b, because they don't have the negative square root of 3 over 2 choice, okay? Which of the following could be a value, right? And so it would be b. So number 17, the correct answer is b. Let's go to 18. Okay, so we're given the graph of f, okay? And consists of two line segments, okay? Let g be the function given by g of x is equal to 2x plus 1. And let h be the function given by h of x is equal to f of g of x. What is the value of h prime of 1? Okay, so what I would first do is let's find h prime of x, okay? So h prime of x would equal, okay, so this is going to be a chain rule because this is a composition. So it'd be f prime of g of x times g prime of x, okay? And so h prime of 1 would have to equal f prime of g of 1 times g prime of 1, okay? Now, we know g of 1, right? Because we have g of x function, right? So the g of x function would be, this would be 2 times 1 plus 1, so that'd be 3, right? So this would be f prime of 3 times g prime of 1. Well, what's g prime of 1? Well, g prime of x would equal 2, right? So it doesn't matter what the x is, it's always going to be 2. So this is going to be 2. So this is f prime of 3 times 2, okay? And then f prime of 3. Okay, so that's the derivative of f at 3, okay? So that's 1, 2, 3. That's right here, right? But it's not the value here, so it wouldn't be 0 because this is the graph of f. It's actually the slope right here at 3, right? What's the slope of this line, right? So we're going, so f prime of, well, this would be 4 minus negative 2. 4 minus negative 2, right? So we're going down 6 and over 3, right? So for this line, my change in y over my change in x is equivalent to 4 minus negative 2, which is 6, right? Over 1 minus 4. Okay, so that'd be 6 over negative 3, which gives you negative 2. So I don't really mind how you did this, okay, but you get a slope of negative 2. That's what's important, okay, because you could have done negative 2 minus 4 over 4 minus 1, okay? So just you get a slope of negative 2. That's what's important, okay? So that means f prime of 3 becomes negative 2 times 2, which would give you negative 4. So the correct answer to 18 is A, okay? All right, so let's go to number 19. All right, for number 19, okay, we want to find the Maclaurin series, okay? And the Maclaurin series means it's centered at x equals 0, okay? So what that means is, okay, when we do the Maclaurin series, okay, it's going to be f of 0. Now, really, this is times x to the 0 over 0 factorial, okay? So if you wrote that, because there's a pattern to this, right? Because this is the 0th derivative, right? So x to the 0 over 0 factorial, and then plus f prime of 0 times x to the first over 1 factorial, right? And then plus f double prime of x, or not of 0, at 0, okay, of x squared over 2 factorial plus f triple prime at 0, x cubed over 3 factorial, and then plus so on, right? Okay, and I only went to 4 because there's 4 terms here, okay? And this would go on forever, okay? All right, so the dot, dot, dot forever, right? So, okay, to do this, 0 factorial is 1, right? So we're gonna find f of 0, and our function is this, right? That's what we're doing the Maclaurin series for, okay? So f of x is equal to 1 over 1 minus x squared. Now, we're going to need to find derivatives of that, right? So it's going to be better if we rewrite this as 1 minus x to the negative 2, okay? So I'm going to start finding some derivatives, okay? So I know f prime of x would be negative 2 times 1 minus x to the negative 3 times negative 1, right? Because we got to take the derivative of 1 minus x, right? And that would be negative 1. Okay, so this becomes 2 times 1 minus x to the negative 3, right? Or 2 over 1 minus x cubed, okay? Now, the second derivative, I would treat this as being 2 and bring my power down, right? So it'd be 2 times negative 3, which would be negative 6 times 1 minus x to the negative 4th power, okay? Because this was 2, right? Okay. And then we're going to take the derivative of this, which would be negative 1, which takes you back to 6 over 1 minus x to the 4th. Okay, I know I'm getting a little bit sloppy with my writing, okay? Now let's take the third derivative, right? So the third derivative would be this 6 times, and then this would be a negative 4 power, right? So that'd be negative 24 times 1 minus x, subtract 1 from the power, so that'd be negative 5, right? Because that's negative 4 power, really. Okay, and then times the derivative of 1 minus x, which would be negative 1 again, right? So this would be 24 over 1 minus x to the 5th power, okay? Okay, so f of 0 now, okay, f of 0 would be 1 minus 0, right? So this is just going to be 1 x to the 0, which is, well, let's go ahead and write x to the 0 over 0 factorial is 1, right? And then plus, what's f prime of 0, right? F prime of 0 would be 2 over 1 minus 0, 1 minus 0. So this would just be 2, right? So this would be 2 times x over 1 factorial is 1. And then plus f double prime of 0, right? So that'd be 1 minus 0, which is 1. So this would just be 6 x squared over 2 factorial, which is 2 times 1. So that'd be 2. And then plus f triple prime, right? So f triple prime at 0 would be 1 minus 0. So this would be 1 again, right? So it'd be 24. So 24 x cubed over 3 factorial, which is 3 times 2 times 1. So that'd be 6. Okay, cleaning this up, x to the 0 is just 1. So this is just 1. And I should put plus dot, dot, dot. And then plus 2x. And then plus 3x squared. And then this would be plus, and this would be 4x cubed plus dot, dot, dot. Okay. And so the correct answer would be C. Now, they're not going to ask you which of the following, right? They're going to say on the test, okay, what is the Maclaurin series for 1 over 1 minus x squared? Okay. And I would say this is a really straightforward, well, it's a straightforward problem, but it's not a textbook problem, okay? So they're going to, I think this is like a type of question that they're going to test you whether you know your BC material or not, okay? Something like this, okay? That's what I would do if I were giving you a test on this, okay? All right. Okay, so that's number 19. Let's go to number 20. Okay, so for number 20, we're given the graph of f, right? And we're giving the function g, okay? And g of x is defined as an integral function. So, and we want to find the line tangent to the graph of g at x equals 5, right? So what we need to be able to do is we need to find g of 5, because that'll be the point, right? And then we need to find our slope at 5, right? So g prime of 5. So we need our slope and our point, okay? So g prime of 5, let's do this one first. Okay, so g prime of 5 is the derivative of this would be the derivative of this, which would simply be f of x. That's the fundamental theorem of calculus, right? So I should say this, g prime of x is equal to f of x. Okay, so then g prime of 5 is equal to f of 5. And f of 5, well, we have the graph of f, right? So the value of f at 5 is -1. So that means g prime of 5 is equal to -1. Okay, now to find g of 5, that's an integral, right? So g of 5 is equal to the integral from 0 to 5 of f of t dt. Okay, so that would mean, I'm going to move over a little bit. So g of 5 is equal to, okay, so it's this area right here. Okay, so this would be 1 times 1, and then plus, and then 1/2 1 times 1. This is not the only way you could do it. You could see this as a trapezoid too, okay? And then we're going to stop it at 5, okay? So we're going to go all the way to 5, not all the way to 8, but all the way to 5, right? Because we want to find g of 5. Okay, so from here to here, right now my function is below the x-axis. So I can use area, but it's going to have to be negative here, right? So I'm going to have to minus 1/2, and this would be 2 times 2. Okay, and I'm up to 4 right here, right? Okay, so then now I have to do this little part between 4 and 5, which is also going to be negative, right? So this is equal to, okay, so this little area right here would be -1, right? So it'd be, well, I should say minus. Let's put minus here. Let me take off that equal sign right here. Okay, so I have this square, triangle, big triangle, square right here that has to be negative, right? So -1 times 1, or -1 times 1. And then minus, and then this little triangle right here is 1/2 1 times 1, right? So g of 5 would equal, this would be 1 plus 1/2 minus, okay, and this would be 4/2, right? Which would be 2, so -2, minus 1, and then minus 1/2, right? So this 1 minus 1/2 cancels out, and 1/2 minus 1/2 cancels out, okay? And we're left with g of 5 is equal to -2, okay? So that would mean that y is equal to my slope, which is -1, times x minus 5 minus 2. Okay, now you look at these and they're not written in that form, right? It's just a different format of point slope form. We're moving the -2 over to the other side, so it becomes y plus 2 is equal to -1 times the quantity x minus 5, okay? And so that is the correct answer, would be E, okay? So E is our correct answer for number 20. Okay, so let's go on to number 21. So for 21, this is more of a reading problem, okay? And kind of not necessarily all about calculus, okay? This actually has to do with this meaning of what does it mean to be proportional to its surface area, okay? So we have a cube, okay? And it's basically, this cube is getting bigger and smaller. Its edge length is x of t. So the length of the edge is dependent upon the time, okay? All right, so if the volume of the cube decreases at a rate proportional, okay, so volume of a cube decreases, that would be dv dt, right? Because if it decreases at a rate, then we know its dv dt is negative. And if you look at all these, they're negative, right? Okay, so we know dv dt is equal to a negative value, right? Because it's decreasing at a rate proportional. Now, proportional means some constant times, okay? So proportional to the surface area of a cube, okay, is, okay, so a cube looks something like this. I'm trying to draw a cube. Okay, and its surface area is the surface area on the outside. Well, if it's a cube, these faces are all squares, right? And there's 6 of these, right? So this is minus, and the proportional part means it's some constant k times, okay, and then its surface area, right? And its surface area would be 6 times x squared, okay? So if you look, okay, that's all we could get out of this. Like if this was just a question they asked you, they'd have to give you more information to figure out the K, right? Basically this is just elimination. Like it can't be this one, it can't be that one, it can't be that one, it can't be that one because of the wording of it. All right, so it's got to be A. Okay, now what happens is this K turns out to be and the multiple times 6 that would give you this negative 1.2. What's important is that you realize this is x squared. Okay, so this right here, okay, would have to be equal to, or negative K times 6 would have to equal negative 1.2. Okay, and then you could figure out what the K is just by solving this for K. Okay, they didn't ask you to do that, right? They just, so the correct answer is A. Okay, and it's the only one with x squared. Okay, that's why it has to be that one, because the surface area would be a square, right? A square unit. Okay, all right, this is a function of t, right? So this is getting bigger and smaller, right? Okay, all right, so that's the correct answer for 21 is A. Okay, so for 22, which of the following is true about the curve of x cubed minus xy plus y squared is equal to 3 at the point 2, 1? Okay, so I'm going to grab another piece of paper because I'm going to have to take the derivative of this and put 2, 1 in and see what the heck happens here. Okay, all right, so I'm going to grab my paper. Okay, and so this is 22. Okay, and I know x squared minus xy plus y squared must equal 3. And then I want to figure out what's happening at the point 2 comma 1. Okay, so I got to do implicit differentiation on this. Okay, so the derivative of this with respect to x would be 2x, and then minus, okay, so this is x times y is a product, right? So I got to use the product rule. So I'm going to put product rule in here in the bracket, okay? So the derivative of x with respect to x would be 1 times y. So that'd just be 1 times y plus your x times the derivative of y with respect to x, which would be, that's where you pick up the dy over dx, and then plus, and then the derivative of y squared would be 2y, and then dy over dx, chain rule, right? Okay, oops, and I should have put a bracket, close the bracket right there, okay? That really needs to be there, okay? And then equals, and then the derivative of 3 would be 0, okay? So this would be 2x minus y minus x dy over dx plus 2y dy over dx is equal to 0, okay? All right, so I'm going to move these, because these don't have dy over dx, over to the other side. If both of these were negative, I would move both of them over to the other side and make it positive, okay? So I'm going to write this one first because it's positive. So we have 2y dy over dx minus x dy over dx is equal to, when I move this minus y over, it becomes positive y. And this positive 2x, when I move it over, becomes minus 2x, okay? And then I can factor out a dy over dx times 2y minus x is equal to y minus 2x. And I'm going to divide by this to get my dy over dx by itself. So that'd be y minus 2x over 2y minus x. Okay, now I want to find the derivative dy over dx at this point 2 comma 1. Okay, so this is the correct notation for, I'm going to slide it up. Okay, so my y is 1, so that'd be 1 minus 2 times my x, which is 2, over 2 times my y, which is 1, minus 2, right? And so this would be 1 minus 4, which gives you negative 3, over, and then 2 minus 2, which gives you 0. Okay, so which of these is true? Okay, so dy over dx exists. Well, when dy over dx at 2, 1, it can't exist, right? So it doesn't exist, doesn't exist, doesn't exist. Okay, does not exist. Okay, and then does not exist. So it's either D or E, right? So which is it, right? So does not exist at 2, 1, and the tangent line at the point is vertical. When you get a denominator that's 0, like this is, that's a vertical tangent, okay? All right? because you can't get the slope there because it's vertical, okay? It wouldn't be horizontal, okay? It would, if it was horizontal, it would exist, and it would be the reciprocal of this. So it would be like 0 over -3. So the dy over dx would have to come out to be 0, okay? And it would have to exist. So the correct answer has to be this D, okay? All right, so D is the correct answer for 22. Sorry, you guys can't see that. Okay, so correct answer is D. So for 23, what is the coefficient of x squared in the Taylor series for e to the 3x squared over 2? Okay, so this is our function, f of x is equal to 1/2 e to the 3x squared, right? Okay, and then basically, if we know the Taylor series for e to the x, we could figure this out really fast, okay? Okay, so what do we know about e to the x for the Taylor series? It's 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus ... Okay, so if we take this and what is e to the 3x squared, right? So e to the 3x squared would equal 1 plus 3x squared plus 3x squared squared over 2 factorial plus 3x squared cubed over 3 factorial plus 3x to the 3x squared raised to the 4th over 4 factorial, and then plus ... Okay, then we could take this and multiply by half of it, right? So 1/2 e to the 3x squared, because that would be 3x squared, e to the 3x squared over 2, okay? Then this would equal 1/2 plus 3x squared over 2 plus 3x squared squared over 2 times 2 factorial. And all I'm doing is I'm multiplying each one of these by 1/2, okay? And then plus 3x squared cubed over 2 times 3 factorial. And then plus 3x squared to the 4th over 2 times 4 factorial plus ... Okay, so x to the 6th, right? This is going to be x squared. This one's going to be x to the 4th. This one is the one that's going to be x to the 6th, okay? So what we have is, it's this one right here that we're going to look at because that's our x to the 6th, okay? So what's the coefficient of it? Well, it'd be 3 cubed x to the 6th over 2 times 3 factorial, right? So this is the coefficient of x to the 6th right there. So 3 cubed, that'd be 27 over 2 times, and then 3 factorial would be 3 times 2 times 1, so 2 times 6, right? And so that would be 27 over 12, okay? And they're both multiples of 3, so this would be 9 over 4. So the correct answer to this is C, 9/4, okay? This is another example that I think they could ask you this question on the AP exam, okay? And they would just straight out, what is the coefficient of x to the 6th, okay? And you'd have to know the Maclaurin series, right, for e to the x, or the Taylor series. Remember, Maclaurin series is just the Taylor series centered at x equals 0, okay? All right, so the correct answer for number 23 is C, okay? Let's go to 24. Okay, so for 24, the function g is given by g of x equals 4x cubed, and it's a polynomial, okay? What is the absolute minimum value of g on the closed interval, -2 to 1? Okay, so this is a closed candidates or the candidates test, right? Or closed interval test, okay? And so we got to find the critical numbers for g of x, right? And the critical numbers are where the derivative is either 0 or undefined, okay? So we got to find the derivative. So g prime of x would equal, and this would be 12x squared, and then plus 6x, and then that would be 0, right? Because the derivative, no, sorry, minus 6, and then plus 0, okay? And now we're going to set this equal to 0, okay? And then what we're going to do is there's a common factor of 6 here, right? So that's 6, and then we'd have 2x squared plus x minus 1, okay? And that'd be 6, okay? Now this factors, right? And you could use an area model for this, okay? So I know, I'm going to do a quick little area model here. This is 2x squared. This is negative 1. Okay, this is from math 2, right? Okay, so we got to figure out two numbers whose product is negative 2 and sum is 1. Okay, so that'd be 2 and negative 1. So this would be 2x and negative 1x. So right across here, I could factor out a 2x, and that would make this x, and that makes this minus 1, and this would be plus 1, right? And so this factors into 2x minus 1 and x plus 1. Okay, so what x values are going to make this happen? It's going to be x is equal to 1/2, and also x is equal to negative 1. Okay, so now what we have to do is we have to find g of negative 2, g of 1, because those are my endpoints, and then g of 1/2 and g of negative 1. I'm going to grab a piece of paper and do that on a separate piece of paper. Okay, so I'm going to go in order. Okay, so g of negative 2, because that's the left endpoint, is equivalent to 4 times negative 2 cubed plus 3 times negative 2 squared minus 6 times negative 2, and then plus 1. Okay, now on the AP exam, you're going to be able to use a calculator. So on something like this is very straightforward. So I doubt they ask a question like this, okay? But it's good review because, you know, we got to remember absolute minimum, closed interval test, okay? So negative 2 cubed would be negative 8 times 4 is negative 32. And negative 2 squared would be 4 times 3 is 12. And then plus 12. And then plus 1, right? So this would make negative 20, which makes negative 8, plus 1, which would be 7. And negative 7. Sorry about that. I knew I made a mistake there. I'm trying to go too fast, okay? And then let's do g of negative 1. And this would be 4 times negative 1 cubed plus 3 times negative 1 squared minus 6 times negative 1 plus 1. So that'd be negative 4 plus 3 plus 6 plus 1. Okay. And then these two, this make negative 1 plus the 1 would cancel out. So we'd be left with 6. Okay. And then let's do g of 1/2. I'm going to slide it up a little bit. G of 1/2 would be 4 times 1/2 cubed plus 3 times 1/2 squared minus 6 times 1/2 and then plus 1. So this would be 1/8. So that makes 4/8. And this is 1/4. So that makes 3/4. And this makes minus 6/2 or minus 3 plus 1. So this is 1/2 plus 3/4. And I'm just thinking of ways to do this. Okay, then this would be minus 2. And let's get these to be fourths. So this is 2/4 plus 3/4. And this would be minus 8/4. So this would be negative 2/4 or negative 1/2. Well, hold on. Negative 3/4, right? Because this would be 5/4 minus 8/4, which would be negative 3/4. Okay, and then we need to do g of 1. That one's going to be the easiest one. Okay, so this would be 4 times 1 cubed plus 3 times 1 squared minus 6 times 1 and plus 1. So this would be 4 plus 3 minus 6 plus 1. So that would give you 2. Okay, so you're looking at, okay, what's the absolute minimum, right? So you're looking at which of these is the smallest, right? And it would be at negative 7, right? Negative 7 is the smallest of these 4, right? So that would be the correct answer would be A, negative 7, okay? And I circled it and I didn't show it to you, okay? So let me slide this down, okay? And so 24 is, correct answer is A. Okay, so then for number 25, okay, they're giving you a differential equation with an initial condition. If it's a differential equation like this, we're going to do separation of variables. E to the y plus x, okay, so we're going to rewrite this as dy over dx is equal to e to the y times e to the x, okay? Which means dy would have to equal e to the y times e to the x dx. So I got to get this e to the y over to the other side, right? And then integrate, okay? So this becomes 1 over e to the y dy is equal to e to the x dx. I'm going to integrate both sides. This needs to be rewritten as e to the negative y is dy is equal to the integral of e to the x dx, okay? So if we let u equal negative y, then du would be negative dy. So I need a negative dy here, right? And I can get that by putting it here on the outside. So that'd be negative integral of, and it would be e to the u and then du, right? Okay, and then that's equal to the integral of e to the x dx. You would not have to do a u substitution. If you could just do it in your head, that's fine. Not everybody can do that, okay? All right, so this would be negative e to the integral of e to the u is e to the u, right? So this is negative e to the negative y is equal to e to the x plus some constant c, okay? All right, so now it's a matter of, okay, do you either solve for y or do you solve for the c? And I'm going to choose to solve for c at this point, okay? So I know if I put 0 in for x, I'm going to get negative natural log of 4 out, okay? So this is my y is negative natural log of 4 and my x is 0, okay? All right. So this is going to be negative e to the negative of negative natural log of 4, which is natural log of 4 is equal to e to the 0 plus your constant c, okay? Now, these are e to the natural log is going to undo each other, right? And you're going to be left with negative 4 is equal to e to the 0, which is 1, plus c. Moving the 1 over, you get negative 5 is equal to c. Okay, so now I'm back up here to right here, okay? And I'm going to put negative 5 in for c, okay? So this is negative e to the negative y is equal to e to the x, and instead of plus 5, it's really plus negative 5, which is minus 5, okay? Now, the next thing I'm going to do is I need to get rid of this negative right here, okay? Because I'm going to want to exponentiate, but I don't want to exponentiate a negative value, right? Okay, so I'm going to multiply both sides by negative 1, and that would cause it to be e to the negative y is equal to, and this becomes a negative e to the x, and this becomes plus 5, okay? So I'm going to write that as negative e to the x plus 5, okay? And now I'm going to take the natural log of both sides because that would get this power down, right? So then this is the natural log of e to the negative y is equal to the natural log of negative e to the x plus 5. This becomes negative y is equal to the natural log of negative e to the x plus 5. And then multiplying both sides by negative 1, I get y is equal to negative the natural log of negative e to the x plus 5. Okay? And that would be, the answer would be C. Okay? And that's 25. For 26, okay, they're asking you which of the following series converge, okay? And so we got to establish the convergence of each of these, okay? So I'm going to go and I'm going to do each of these individually. It's going to take a little bit of time, okay? But I'm going to do each of these individually to determine whether they converge or not, okay? So I'm going to grab another piece of paper, okay? Okay, so the first one was sigma n equals 1 to infinity of the absolute value of sine of n over n squared. Okay. And what I want to do is I want to compare this to 1 over n squared. Okay. So, and I'm going to do, it's going to be a direct comparison test. That's what I'm going to use. Okay. Because I know that the absolute value of sine of n over n squared will always be less than or equal to 1 over n squared. Okay. Now, what I know is that 1 over n squared, so, and we know that this, so sigma n equals 1 to infinity of 1 over n squared converges by the p-series test. Because p is equal to 2 in this case, and p is greater than 1, okay? So I know this one converges, right? And, okay, and the absolute value of sine of n. Now, the biggest sine of n can be is 1, right? Okay, and or it's sine of n is between negative 1 and 1. Okay, but when you take the absolute value of it, this number right here has to be between 0 and 1. Okay, and if it's between 0 and 1, then this would have to be less than this one. Okay, so by the direct comparison test, okay, so I would say sigma n equals 1 to infinity absolute value of sine of n. This is the proper write-up. That you wouldn't see this in a multiple choice question, okay? So n equals 1 to infinity, absolute value of sine n over n squared converges by the direct comparison test. Okay, so maybe I didn't say enough about this. Okay, if the bigger function converges, okay, and that's the one we're establishing, right? We know, and this one's smaller than it, right? By the direct comparison test, this one must also converge because this one is sandwiching this one. Okay, all right. Now, the divergence of direct comparison test is if the smaller one that we know that's established, that we know that one diverges, right, and the one we're looking at is bigger than it, then the one that we have must also diverge. Okay, all right. Okay, so now let's look at the next one, right? So the next one was sigma n equals 1 to infinity of, let me grab it, e to the negative n, right? E to the negative n. Okay, so what you have to realize is that this is n equals 1 to infinity of 1 over e to the n, right? And that can be rewritten as n equals 1 to infinity of 1 over e to the n, and that's a geometric series, right? And this 1 over e, now e is 2.7, right? So this is less than 1, so we're going to know it converges, okay? All right, so this is, so this series right here is a geometric series with r equal to 1 over e, okay? And the absolute value of 1 over e is less than 1. Therefore, okay, then it converges by the geometric series test. Okay. All right, so it converges by the geometric series test. Okay, and then the next one was sigma n equals 1 to infinity of, I have to pull it up, n plus 2 over n squared plus n. Okay, now I'm looking at this, and this, if we just look at these, right, as the n goes to infinity, right, these are going to go and become 1 over n, right? If we disregard these two, okay? So I'm thinking I want to compare it to 1 over n. And for this one, I want to do the limit comparison test, okay? So so our a sub n is n plus 2 over n squared plus n, and my b sub n is going to be 1 over n, okay? Now, we know that sigma n equals 1 to infinity of 1 over n diverges because sigma n equals 1 to infinity 1 over n is the harmonic series, which diverges. And I just realized you guys can't see it. Okay, so diverges, right? Okay. So what we want to do is the limit comparison test says, okay, if we get a limit out of this, right, and it's positive, it's an actual value, okay? And if it's a positive value, then we know whatever this one's doing the same thing, okay? So we're going to take the limit as n goes to infinity of a sub n over b sub n, okay? So that'd be the limit as n goes to infinity of a sub n would be, I'm going to put parentheses around this, it'd be n plus 2 over n squared plus n, okay? Now, this is, you can think of this as being a sub n times 1 over b sub n, and 1 over b sub n would be the reciprocal of this, right? So this would be times n, okay? And so that gives you the limit as n approaches infinity of, and this would just be n squared plus 2n over n squared plus n, because n is going to infinity and we're looking at the magnitude, right? These are going to cause the most growth, right? That's just going to be equal to 1, which is a positive value, okay? All right, so since that's a positive value, I'm going to slide this up just a little bit. Okay, so since this is a positive value right here, okay, and this one diverges, they're going to behave the same way, okay? So we know that n equals 1 to infinity of n plus 2 over n squared plus 2n diverges by the limit comparison test. Okay, so the only two, it's 1 and 2, those are the only two that will converge, okay? So I'm going to go back to the multiple choice part of this. Okay. And so the correct answer would be D. Okay, let's go to 27. All right, for number 27, we're given this integral from 1 to x f of t dt is equal to this, the 20x over the square root of 4x squared plus 21 minus 4. Okay, so basically this is the antiderivative, right? Okay, so then the integral from 1 to infinity of f of t dt is, okay, so let's write this up. This is how you'd write it up. 1 to infinity, okay, of f of t dt would equal the limit as b goes to infinity of the integral from 1 to b f of t dt. But we know this integral is this, right? So this becomes the limit as b approaches infinity of, okay, and it'd be 20b over, because x, the b's in the x spot here, right? So it'd be 20b over the square root of 4b squared plus the 21, and then minus the 4 on the outside here, right? Okay. All right, so this actually becomes, we're looking at magnitudes, right? So this is 20b over the square root of 4b squared, okay? So this is equal to the limit as b approaches infinity of 20b over the square root of 4b squared, which would be 2 square root of b squared, which would be 2 times the absolute value of b minus 4. Now, because b is going to infinity, we really don't need this to, we don't need the absolute value, right? I mean, that's what it is, but we wouldn't need it in this situation, okay? So this would be basically 20b over 2b, or this would be 10, right? Okay, if b goes to infinity. So these are going to cancel out, and we're going to be left with 10 minus 4, which would come out to be 6. So the correct answer is A, 6. Okay, let's go to 28. So number 28 is x equals t squared minus 1 and y equals natural log of t. This is a parametric equation, okay? And so we're not going to do it because that's not going to be tested this year. We'll do this after, I'll show you how to do these types of problems after the AP exam, okay? So don't worry about 28. We're going to cross that one out, okay? That's not going to be tested. All right. All right, so that's 15 through 28, taking out 28 because it was a parametric equation. Okay, hopefully you're picking up. If you're getting, half of these right, you're doing good. Okay, you're getting a passing score. If you're getting half the problems right, and it seems like these are really hard problems. So you guys look at this and you think that, I'm not doing well. Well, you got to realize that these are written for really top students, and also some of the lower students, right? To see where you land. Okay, so don't worry about it if you feel like, man, these are really hard, because they are. All right, so just give yourself a little bit of a break, and if you're getting half of these right, I'm really happy. Okay, I'm happy for you. You're doing a good job. Okay, so I just want to tell you that. All right. Okay, so keep it up, and we'll do some free responses tomorrow. Okay, you guys take care. Bye.